All right, go. All right, Abdul, you ready?
Yep. Okay, hello everyone. Today we're presenting our project, BOLD, which is the Bayesian Online LiDAR Detector, and we are Farid Khan and Abdullah Hassan. So we'll be going, I'll just be introducing a little bit, and we'll be talking about the type of classifiers we've used, the architecture, and the implementation of our project. So what is fake news? Fake news is content or misinformation designed to manipulate, spread propaganda, or support the claims of a specific group. Claire Wardle, in her 2017 article, Fake News It's Complicated, actually identifies 7 types of fake news. There's satire or parody, false connection, misleading context, false context, imposter context, manipulated content, and fabricated content. And a Stanford study from 2016 shows that students, both in public schools and across the K to 12 grade levels, as well as university students, struggled to identify fake news from real news, whether it was tweets or whether it was photo-based posts that they were given to assess. So we've used 4 classifiers in our project. I'll talk a little bit about Bayesian on the next slide, but we use logistic regression, which is similar to linear regression, but it has more of a classification focus. We used SVM, which is, again, another classifier, similar to clustering, but it tries to divide the data into different planes, and random forest, which is similar to a decision tree. So as the title of our project suggests, we're primarily focusing on the Bayesian model. It's a technique in which prior experience is updated as more data is available. So unlike some of the other algorithms, instead of assigning directly to a single class, it actually generates probabilities for each class to try and identify which one would be best suited per the data. The data set that we used for our project is the LIA data set, which was put together by William Yang. This data set is built up using the PolitiFact API, where search statements made are assessed to be true or false on a scale of 6 classes, where you have true and false, but in between you'll have pants on fire, obviously extremely false, or stuff like half true.
So-
Farid will explain the architecture.
Yes, thank you, Abdul. So now we will look at the bold architecture, and it's a simple framework in which what we tend to do is use Python to program the model on, and we tend to use sklearn framework. And then there's a data set or the database which is used, which is used for the training, which is on the layer set. And at the same time, there's a user framework built on Postman and Flask, which allows the user to be able to search in time whether the news content is true or false. So as for the implementation, we would like to show a small little demo of what we have been able to accomplish. Just one second. So just a brief description about our code. This is what is used as for to train the model on and to be able to make the Bayesian model tend to work. The data set that we are using is just as for a sampler is something similar to this, which has 6 different classifications or 6 different labels which are used in terms for the to show whether the statement is true or false. And here basically we are extracting the labels and making them into categories or numeric formula. This is just to describe or to show the distribution of the data that we have. This is what the vectorizer basically makes it into numeric vector form, which is then used for each and every word is converted into numeric vector form, which is then fed into the model that is to be trained. This is where the test size and training size is split into. So you have 70% that is tend to be used as for training and the rest is used as for the testing purposes. This is where we are using just for the benefit of it, just to test out how does different classifiers to do perform. So we tend to use 4 different ones right here. This is the k-folding technique that we tend to apply to the training set. And this is where the graphical formulation of our model is prepared. So just to show how it runs. So this shows the distribution of the training set. So there's about 10,000 values. This is the distribution of our training set, or I'm sorry, testing set. Just one moment as the process is coming to an end. All right, so this is a box plot, which simply shows the accuracy rates that we tend to see here of all the 4s, in which we see that the Bayesian and the logistic ones are the better performers. This is the convolution matrix that we tend to receive. So it shows the distribution of and the level of accuracy that is reached in each with respect to each label, and so the final result is what we do see is right here with naive with the Bayesian and the logistic as being the better performers. But then the question actually comes to rise is that one moment. So as we do see here are the following results that as we tend to receive on the liar data set. So the major question that comes to rise is that why the accuracies tend to be so low. Well, the actual reason is that the benchmark value or the highest percentage in terms of accuracy that was reached on liar data set, as for published work, is in the William Wang's publication, in which he tends to show about higher than 85% till 90% of accuracy rates. And but on the other end, we have also seen many different programs and applications in which the ratings on this data set has been lesser than 40%. And a lot of the reason that has to do with it is on the pre-processing of the data set and how the data set is actually being used or conducted. I think that plays a very key role, that how the structure of the data itself. So the techniques and the ways that we can foresee to do in terms of getting better accuracies is through using much more novel and much more sophisticated based algorithms, which probably is going to be using TensorFlow with a very interesting deep design in order to get higher and better results in terms of using deep learning models. In future results, we expect to do that with the liar data set. And so, as I was trying to get my point across, is that liar data set is a benchmark for fake news detection and a technique for text classification. So, although that we do have a lower accuracy rate, but it still is able to perform to a very high extent and to be able to get some results. And we expect that better results are much more possible through using different framework and deep learning model, and which will be dependent on TensorFlow itself. And another very key aspect that we tend to see is that context play a very key role in detection. So a lot of times these data sets, as we're pre-processing it, they didn't contain the context aspect to it, which I believe that we can be used as additional vector input that can help us to get even much more higher and better results in terms of accuracy. And these are the references that we tend to use for our model and our project. And if any further questions, please let us know. But thank you for your time.
Thank you.